Welcome to the Institute for Strategic Policy Solutions. My name is Kimberly Jackson, and I'm the Executive Director. We are honored to be here at the Chris Sprowls Innovation Center at the Tarpon Springs campus. And before I begin, I want to thank Rod Davis, the provost of this campus, and Shannon Ehrlich, who is one of our assistant deans, for their tremendous help and support in putting on this 3D program. A lot of what we do at the Institute is to make sure that students understand the appropriate scope of government and policy and how their future lives are impacted by both. We have the honor of doing both today. The Institute is a gift from Congressman Bill Young. It was created to make sure that students had this forum and space to discuss and explore issues related to politics, economics, and social mobility. Thank you so much for your time. We invite you to go to our website to learn more about the Institute. And with that, I'll introduce my colleague, Aaron Bryce, who will introduce our panel today.
Hello, my name is Aaron Bryce, statewide coordinator here at ISPS. Today I have the privilege of introducing our esteemed panel. Today we're joined by Chad Mairn as our moderator, who serves as a professor and founder of the Innovation Lab at St. Petersburg College. As an undergraduate at University of South Florida, he received a Library of Congress Fellowship to archive materials in the Leonard Bernstein Collection. During his graduate studies in library and information science at USF, he served as a technology liaison between the Bill and Melinda Gates Foundation and Florida Public Libraries. We're also joined by David Yocum, a teacher at Millennium Academy Private School and Advanced Manufacturing Career Technical Education Instructor with Pasco County Schools since 2020. We're also joined by Tim Widmann, the Hub Coordinator here at the Chris Sprowls Workforce Innovation Hub and Adjunct Professor of Engineering. He holds an MS in Entrepreneurship and Applied Technology, a BS in Supervision and Management, and an AS in Drafting and Design Technology. With 36 plus years of experience in manufacturing, construction, welding, fabrication, and estimating, and 10 years specializing in 3D printing, Tim is the author of Additive Manufacturing, A Guide to Skills and Design, and has owned multiple manufacturing companies. Please help me welcome our panel here today. Thank you.
How is 3D printing transforming traditional manufacturing processes? And you kind of mentioned this a little bit. Are we moving towards a future where 3D printing completely replaces traditional methods, or is it more of a complementary technology?
I would say it's still going to remain in a complementary area right now, though the speed has increased dramatically. We cannot compete at the speed of injection molding, but that doesn't mean that we're not able to use it in other areas. So space programs have fully welcomed additive manufacturing over traditional manufacturing. In fact, all the rocket engines that are currently being used right now are all 3D printed. You no longer have traditional manufactured rocket engines. So the Raptor, the Dragon engines, those are all 3D printed rocket engines. So the technology that we're using to create those, we can't use subtractive manufacture to make the same type of engines because a mill can't hew its blade down a helix, where additive manufacturing will allow you to do that.
Well, absolutely. With the advancements in all these industries that I work with. So I used to be a race car mechanic. I got distracted from my airline career kind of focus and professional aviation career, and I started fabricating race cars. And that was all sheet metal work, working with your hands, cutting things, making custom pieces where I just have to figure it out and make little templates and, trial by error. Well, now I can take a 3D scanner, I can scan the front of my car, do everything in the computer, create the bumper I want, even check the aerodynamic airflows and make sure the screw holes are where they need to be, and then print it. And it saves so much time. And then I always have that file to replicate it and make another one. So just that part alone, I think is huge benefit to the 3D printing industry.
Yeah, the prototype levels that you can reach rapidly with 3D printing well outshines what you can do in standard manufacturing. So the hours and hours that you would spend out at a car trying to fit something to a bumper manually using a piece of sheet metal and markers and all these different things to get it to fit, you no longer have to go through that. As he said, Dave said, take a scanner, scan it. Absolutely. Scan it, throw the model into your computer. All that man hour goes away. So you save tons of time.
Yeah, and I'd like to add something about the 3D scanning too. So not that long ago, it was a few months ago, I had a student who wanted to scan some kind of a part from a bow and arrow. And we had a $25,000 scanner. And we were like getting all fancy with it, trying to scan this thing, and it was horrible. It did not work. So I took out my trusty cell phone, put a 3D scanning app on it, and scanned it beautifully with my phone. So now pretty much everybody that has access to a phone can 3D scan pretty much anything and then manipulate it in the computer or whatever they need to do down the road. So that's just kind of overnight. Our phones have LiDAR scanners built into them now. It's incredible. Drones can now fly around and scan full areas, and then that can become, a 3D model. So it's incredible what we can do with that. So, so you both touched on this a little bit. So while 3D printing offers incredible potential, cost, and scalability, they all remain concerns, right? So what advancements have been made to make 3D printing more cost effective and scalable, especially for those large production runs?
Well, the bamboo lab definitely takes the cake right there. I mean, you just, it's not very big, but you can make a big impact. And there's a lot of other manufacturers out there now that are making bigger printers. There's a lot of innovators. Even here in Tampa Bay, I work with a few people that are building their own printers and using available software to really bring their innovative uh, additive manufacturing to the next level.
Yeah, the size has increased greatly. My first 3D printer printed a 4-inch by 4-inch by 4-inch space. So this is printing basically 10 by 10 by 10 in general. It's a little bit smaller than that. When we look at some of the other types of printers out there, SLS, selective laser sintering, that's taking a powder and hitting it with a laser and creating layer by layer. Some of those machines have gotten enormous. WAM has given us the capability of, as long as the arm of the robotic arm on the machine can reach, that's your build area. 3D construction actually allows us to build buildings that are over 3 stories tall with 20,000 square feet. So the limitations have gone away in how big we can print. And there's always the capability to print small pieces and put them together. So this is actually 6 pieces. The possibilities are endless. So if you think it, you can print it.
So I do have a little bit more to touch on. Um, so we all talk about going to the moon. There's a lot of talk about space travel these days, and everybody wonders what these 3D printers, how we're going to get a 3D printer on the moon, and how we're actually going to use materials or bring materials. It's just not efficient to bring materials to the moon. Just for this right here, it's $1 million to take that to space, for example. So being able to use materials that we find naturally, like moon dust, a regolith, I do believe they call it. They have 3D printers, kind of like SLS, that will use moon regolith to actually 3D print structures on the moon. So really, we just need to get a 3D printer on a rocket or parts of a 3D printer to replicate and start building our habitats in space. And I mean, that could even help, here on Earth.
Oh, yeah. Icon Construction out of Texas was hired by NASA to actually develop in Texas a faux area for a 1-year term for astronaut not to participate in the experiment of living on Mars in a 3D printed facility. So you have that capability here. We can get that capability there.
And I don't know if you remember reading about it, but it was a few years ago. The International Space Station needed some kind of a screw or like a tool, wrench or something. I forget what it was. So they were able to email it to the space station. Then they were able to 3D print the part, fix whatever they needed to fix, and then you can recycle that. It's easy to kind of recycle plastic, so you can reuse it again if you need to. So that's incredible. And then going back to the size of the 3D printing, an article just came to me the other day, and they're 3D printing artificial coral reefs now, which is just mind-blowing what you can do with that. So anything else you want to add on that question?
Well, just for an idea, Tronxy is one 3D printing company that currently makes a 3D printer that's less than $5,000. That is 1,000 millimeters by 1,000 millimeter by 2,000 millimeters. So 1 meter by 1 meter by 2 meter print area for less than $5,000. So the capabilities have expanded out. The costs have come way down. So I think 20 years ago, a 3D printer was roughly $800,000. And now you have printers similar to this, not the same quality, but still at $500. So, yeah, we're advancing greatly.
There's one,
Sure. Yeah.
the one thing that I think that has been kind of ignored is, this Bamboo Lab makes a little bit of extra waste in some of the older computers. And how many of you use water bottles? A water bottle and a cap. I'm hoping, and I know some of this stuff exists, and you can see it with the right budget, right? But you take the water bottles, your garbage, any plastic garbage, and basically put it in a separator that creates extrudable materials for FDM printers right in a mobile solution. That, I think, could be the next step to where we don't need filament because we create our own.
There are some that actually have pellet capability. So they pelletize the plastic, it goes into a vat, it's gravity fed down in, and then that gets converted into filament that can then be 3D printed.
Yeah, that's amazing. So now let's shift a little bit. So how are 3D printing and design being integrated into educational curriculums at different levels? So what key skills should students develop to take full advantage of this technology now and into the future?
I deal with that a lot because of teaching engineering. My drafting students, I bring the idea of what you're creating could actually come right in, be turned into an STL file, and 3D print the part that you just finished drawing. So I use it directly with the students that I work with and making them understand that this could be your future for your own business. So not necessarily just working with someone else, but you can create your own income, generate income off of it, develop your own business. There's a gentleman that's online. He made a business out of his garage with 3 3D printers. And when I show that to students, they're completely astounded that this guy now makes $5.4 million a year 3D printing Nerf gun parts. So it comes down to making them understand that you can build a sustainable income if you know what you're doing and what to do with it.
And that brings me to a topic, doing what you love. If you find something that you're interested in, you're going to latch on to that and really harness powers in your passion and find things to make it lucrative. For example, 3D printing parts. I have a very good friend also that has developed a business to where he 3D prints car parts and then he does carbon fiber overlays and makes custom car parts, which he's very successful at that. And I've had some awesome experiences to do training, even from an adult level all the way down to now elementary school. So back when I used to work for aeronautical systems engineering, I would teach soldering, and we had a little 3D printer, and we would make parts and pieces. So I would instruct our staff in how to use that stuff. And then um, I ventured into the high school, teaching high school back in 2020 when we really needed teachers. So I was teaching right up here at Claude High School and exposed the students there by developing a program for AM skills and Claude High School, which was basically advanced manufacturing, and did 4 years of the program to where each year, and you got to look at the industry, everything's evolving so like constantly. This didn't exist when I started teaching. So it's a lot of things that I looked at who I was training, and some of the graduates that graduated from high school. What a pleasant surprise. I run into them here at this facility. I know they're in good hands. But now that I'm in elementary school, teaching what I was teaching the high school kids 4 years ago. So you got to think about the evolution of the industry. Well, we're all going to grow up, and we need to be able to stay on top of that. So I've actually rewound my timeline and gone back to elementary school to really put not only the passion and tell the kids that Lockheed Martin and Honeywell's right in your backyard. Ask your mom. They work, they work for them. Find out what you're interested early on, when you're excited about it, when you're enthusiastic about it. And then you can really use 3D printing, to go anywhere.
He nailed a good thing here, which is we have to look at the future, not at the now. So, and I talk a lot about, vision 25 years from now. That's what you should be building for right now, 25 years from now, not next week, not next month, not next year, 25 years from now, because the odds are a lot of that stuff is already in play. So in 2017, I designed a EVTOL that would carry people. At the time, those things didn't exist. They're still not to that level yet. That was only 8 years ago. We have to be ready to think about the future constantly, with coursework, with equipment, with instruction to the students, and bringing awareness to communities that 3D printing is not just something that some kid is playing video games with. It isn't something that only a dentist deals with. It isn't something that just contractors use to build houses. It's in every part of life.
Yeah, and then to just end with what you just said about the passion and all that. I'm really fortunate that I've got to work with everybody. In the Innovation Lab, we've had 3D printers since the beginning, so that was like the first thing we actually got was a 3D printer. And so I would expose little kids and their parents and middle school kids and college kids, all of them, to 3D printing. So when it first came out, it was magic, right? Like, oh my God, this is amazing. And then they would see the frustrations too when it wouldn't work and all that. But that's part of the learning. So you learn. So then I would get students that would come in, SPC students that would come into the lab. And I had one student in particular who said, I want to build one of these things. So we started using the rep wrap printers, and we started 3D printing our part for the printer. We got it to kind of work, right? What was cool though is me and the student, we actually published an article on the process. It's the process that's important, right? The end product didn't quite work. We got it to move. It kind of printed a little bit, but it wasn't fantastic. So now that student is at like Raytheon doing amazing work. And then I've got a couple other students who would come into the lab, work on robotics projects. And guess what? To create a robotic piece, you need to 3D print parts. So they 3D print in the lab, and now they have their own 3D printer, and they're doing just amazing work. So it's that exposure at an early age, and then they develop this passion for it, and I think that's really important. So yeah, kudos to both of you on that. So let's see, I'm going to kind of skip over a few of these because I think we've touched on a lot of it. So I'm going to go to this one. As 3D printing becomes more mainstream, intellectual property concerns are emerging. What are some of the major legal and ethical challenges related to IP in 3D printing and design? Um, Remixing as well. That's another part of it. And how should companies and creators address these issues? Kind of a tricky question, but what do you think?
I I think one of the biggest issues that we're facing is the evolution of AI and how easy it is to take something and convert it into a three-dimensional item, especially when it's something that was already 3D printed. They can say they designed it themselves, but they didn't. So anything that's designed with AI automatically is stepping into that grounds. Just as if a student were to use AI to write a paper, that's not their work. It's AI's work. So limiting and keeping an eye on that alone is hard enough. Then you have countries that feel, well, you designed it. I'm just going to go ahead and take it and do it myself. We have a problem there. And it's going to be a bigger and bigger problem if we don't grab a hold of it and say, there's a license on this. You cannot use it. It's got to extend patent wide of the design. Um, and sometimes it's hard to get those patents in place to stick through the patent departments around the world. There's several patent agencies. There's not just the United States Patent and Trademark Office. So when you got a patentable item out there, how many people do you have to go through? China's got patents, Russia's got patents, India's got patents, Europe's got patents. So Japan has their own patent office. So when you run into all those different things, we have to be sure that those electronic files are also protected.
Yeah, speaking of that, I wonder if there's a way, I'm going to go off on a tangent for just a split second. Blockchain, right? We hear all about it. It seems like that would be a good place for blockchain. You have an original file that I created, and as it gets verified on the blockchain, it goes down the line, and then you get it, and you're like, oh, I'm going to make this adjustment. Well, then the blockchain makes that change. So now I can see the zeros and the ones have changed and go, oh, wait a minute. So he's taken it and he's remixed it, which is fine. I've given permission to do that. So that might be a way to kind of tackle that problem. I don't know. But anyway, just a thought.
That sounds logical.
So I started working with Roy Kirshner. Unfortunately, he couldn't be here today. Back in about 2016, and I was working at Aeronautical Systems Engineering, building simulators. So one of the things that I encountered when I went over to Roy's, the prototyping process. Originally back in 2018, a lot of the manufacturers would take a prototype and send it to Europe or send it to China or send it to, send your idea abroad. So there it goes. It's across the pond now, and you've given it to this manufacturing facility that hopefully is going to send you a product in 2 to 3 weeks or several months. So being able to replicate and build things yourself and make your own files obviously will keep you out of that problem, but we don't have to give away the information now and send a file out to China to have it replicated when they might take it. So, I understand. And you look at the students, a lot of times you put them on the Tinkercad and they immediately go and click the already pre-made designs. And they're like, oh, look what I made. No, you didn't. So you have to give them that guidance of that's not yours. I know it was a shortcut. You got this fast, but it's not what we need,
Right. And what he's talking about, the two end files there were files that other people created. The guitar was a file someone else created. The clay pot, I drew in AutoCAD and then 3D printed it. So you have the point of who designed it is the important factor, because the design in itself is where the man hours are in 3D printing. 3D printing so rapid, you set it, you forget it, you walk away, you come back later and it's done, which this one will be done in 3 minutes. So it's a set and forget. The thing that's in here is that's printing has been around in 3D printing for about 20 years now. A benchy. Benchies are benchmark. But in 3D printing, we have a boat, and it tells us if our layers are right, if we're adhering to our build plate properly. Is the temperature right? Are we having separation issues? So that's how we use this benchmark. In subtractive manufacturing, we use a 1, 2, 3 block to machine and make sure that the machine is running properly and keeping everything square. But the personal property that you developed, that intellectual property is your design. It's not the finished product. It's the electrical item. And I agree with you that if we take it blockchain, we'll protect our personal designs.
No, good point for sure. So I'm gonna this is my last question. So where do you see the future of generative AI, design, 3D printing in the next 5 to 10 years? So do you see any emerging trends or applications that could radically change the way we use 3D printing in our daily lives and industries? And particularly, let's include the healthcare industries because of all the prosthetics and all that stuff. And you can go beyond that if you want, but I'm just curious to see what you think.
Well, I've seen 3D printed used in just about every aspect. Clothing, food. You can find shoes now with the slip-in Skechers. The heels are 3D printed. Housing, cars. Relativity rocket was an entire rocket 3D printed and shot into space. There isn't a field out there that hasn't been touched. Food, 3D printed organic steak, chocolate. Baristas are using it to create the tops of your coffee so that you have a fancy design on the top of your coffee. There is not a field that additive manufacturing cannot get involved with, and odds are something in your life that you see on a daily basis has been 3D printed already and that you're holding somewhere along the day. So it's now coming down to, can we do it faster? Can we do it better? That's the bottom line.
This question requires a bigger budget because we're limited to our budget, right? I have tons of ideas. I'm sure if I had the budget, I could be on my way home, talk to my personal AI assistant, tell them what I need 3D printed, and a robot arm is going to scoop the old one off, start the new print. Oh, let me make these adjusted. I could see it really being advanced with the AI to where you basically have an assistant helping you with your printer, with your files, with the problems that the files might have that you might not identify right away. And then, space, living situations, building houses with 3D printing. A lot of innovative things are happening now, like you said.
Spark 3D, it's an AI. You can literally take a 2-dimensional drawing, put it into it on your computer, press generate, give it a few minutes. It will develop a full 3-dimensional model of that 2-dimensional image you put in there. You'll be able to convert that over to an STL file and have it in a printer in just a short period of time and printing for you without ever having drawn it in 3D. So AI can help us greatly, but it can also be our worst enemy. It comes down to how we police its use.
Yeah, and there always has to be a human in the middle, right? That's just another fact. So that's all I have. Now, do we have any questions out here?
Thank you for those of you that just joined us.
Here, I can read it for you. Are you going to read it? Oh, good.
Hello. I have a question. So, how does AI and automation influence the next wave of 3D printing innovation? especially in small to mid-scale manufacturing?
All right. So AI currently, what some companies are doing is actually integrating with AI to use robotics to actually feed the machines, remove the equipment from the machines, and it's a fully autonomous shop. So you're not even in there. And when you have that type of a situation, for instance, in Italy, there's a pizza company that does not have a single employee. It's all robotic. The person comes in, punches in their order. The robotic arms create the pizza. You flash your receipt when your pizza is ready and it delivers you your pizza. That same type of knowledge is being used in manufacturing to where a person in a room just punches in what they want done and then they walk away and then the machine just keeps going and keep going and keep going. And eventually it just fills up a bin. Another item that's autonomous comes in, moves it out of the way, and the next bin comes up and it fills that one. So these things are currently happening already, and it's only going to scale up.
Yeah, and you think about it, the machines don't get tired. They don't get bored. They don't get annoyed with their they're just programmed to do what they're supposed to do. So it's an interesting time for sure.
Question.
Sure.
With how fast 3D printing technology and materials are evolving, how can someone new to the field stay adaptable and consistent in building the right skills over time?
I think that starts in education. I think in the proper area of education, as long as you're around people who are really focused on additive manufacturing and where it can lead you, then it's where do you want to go? So, as I had said earlier, if you think it, you can print it.
I also think there needs to be a space, sort of like this or wherever, where they give you an open playground to just play. And don't worry about if your print job doesn't work, right? Learn from your failures. That's the most important thing. But to give you that space, I always call it like a technology playground where you can go in and play and just kind of come up with ideas and not worry about the grade and all that, right? So we need more of that in education. It doesn't all have to be curriculum. It needs to be open and let people play. So
Don't be afraid to follow what you're passionate about and finding things in technology that you can actually harness in those areas that you like and love, for example, to where that career not only becomes your life, but your whole life. Your career is your career. You don't want to be miserable, but there's so many things nowadays that, like he said, I don't see where 3D printing won't be used, honestly.
It's where your mind leads you. So, what's your passion? All right. What's your passion? All right. And the understanding that every single engineer out there before they leave a college is going to be 3D printing.
Yeah.
Every single architect that's out there is going to be 3D printing before they leave a college.
True.
All right. You're getting to the point now that every single healthcare worker is going to start experiencing 3D printing before they ever leave a college. It's going to be involved in just about every aspect of what you do in the future. You out there, you're the future. Where do you want to go? Do you want to just keep going and doing the same thing as we've done in the past, or do you want to make it better? How are you going to do it? So look at what your intentions are. Look at what your passion is and build on that. And then you can apply additive manufacturing into that passion. Dentists make false teeth. Doctors now make bones that they can implant. In fact, they now have a 3D printer that will actually 3D print inside the body. We can recreate bones that are diminishing. false eyes, food, cars, planes, you name it, we can do it. What do you want to do with it?
You know, honestly, you all here sitting in front of us, you're going to know what industries 3D printers aren't in. So maybe you can find the industries that need it and take 3D printing with you to that industry and be a subject matter expert.
Do we have any other questions or comments out there? I noticed a few looks when Tim mentioned, 3D printing body parts. There was a couple of like weirded out looks. Does that freak you out? No? Some yeses. Freaks me out a little bit. I'd let them do it if it's going to save my life, right? But anyway, I just saw some expressions that were like, ugh.
I'll throw one at you, which is University of Texas recently 3D printed a working heart. So we are on the precipice of being able to extend life by using 3D printing. That should be a wake-up call, because now we can replace organs that are failing that we couldn't replace in the past.
All right, one last chance. Any questions or comments? Okay, if not, thank you. Thank you, fun.
Well, thank you all for coming today. We appreciate everyone coming out, including the panelists. We're looking forward to a couple upcoming programs. We have the Grand Debate on November 6th at the SPC Seminole campus. They're debating the First Amendment for a chance to win $1,200. If you're interested, you can contact your advisors. And then we have a space bus, big space bus out front, tours for this facility as well. But thank you all again for coming, and thanks for the panelists. Thanks for everyone coming. Thank you.